method is the polymorphisms. Yes. So, and then after we look at polymorphisms, we then look at packages. So when we talk about polymorphisms, what do we mean by polymorphism precisely? Polymorphisms from the Greek word poly means many, morphisms means ways or form. So that is many form of representing objects is what we mean by polymorphisms. Basically, if you look at, we said if we have a class hierarchy, any subclass is of type that class, that is that subclass, and also of type its own superclass. So that means I can say anybody who is an employee is of type employee because he's a member of employee class, and again is of type person because that employee is a person. So this kind of representation, if we can represent an object in form of its own class and also represent that object in form of its own superclass, so this many ways of representing object is what we mean by polymorphisms, basically. So we give an example, which basically, like I said, this shouldn't take us up to 2 to 3 minutes because all we need to say here is how can we represent the object in many ways, looking at the abstract classes, interfaces, and even the normal inheritance. And then we look at packages, how we can organize our classes and related classes together, which I'm sure you have the experience or you must have seen these packages, only that you might not know how to use it. Because if you are using NetBeans or you are using JCreator, NetBeans or Eclipse, they automatically create these packages and organize all the files, the classes in appropriate package. So in that, yes, we don't know how it works. We only just create a project and automatically add it. But in this case, how do we declare it ourselves? And how can we compile and run a program that consists of packages? And why do we need these packages? So we need to understand, why do we need this package? Does that mean every program we come to write must all be in the same package? Then we're going to see the reason whether it is appropriate or not appropriate to have them in a different package like that. So basically, this is it. Now, we say recall what inheritance is all about. Oh, this is what we, so we move straight to polymorphisms. Yes, polymorphisms. Okay, fine. So we see what is polymorphisms, and like I said, many ways or many forms of representing object. And then we see advantage of polymorphisms, which is having way of an object that will be of type that class, its own class, and also of type any class above it in the class hierarchy. Then with this advantage of polymorphisms, we now see how can we, because we say an object is of type its own object is of type its own class and also of type its class above it in the class hierarchy. Then it means if there is need to access a method of the superclass, there may be need to do all the possible ways of upcasting and downcasting, or an object of the superclass to access a method of the subclass, we have to downcast. So we have to do all this possibility of downcasting and downcasting of a thing in order to avoid any possible error, because it's possible that maybe you have a combination of people and you in that why you have people there, but then this is the son of this parent and this is the son of this parent, and you are just looping through to check all the children that you have, but then you want to determine who is the parent of a particular, who is the child of, or who is the parent of a particular child. So to do that, it's possible that all this possible of downcasting and downcasting. So you have to like say maybe if this is an instance of, or that is to say if this is the son of or is the child of this particular parent. So how do you now compare? How do you check this way? So the same thing when we have like maybe we have different types of accounts and mixed together, because if we are dealing with account, let's see now, whether you have saving account or current account or whatever type of account you have, we can still regard that one as an account. So that means savings accounts, current account, domicile account, they are all what? Account. Fine. So if they are all of type bank account, but then we have various types of bank account. And there are methods that are in, possibly we have some method in the bank in the current account which might not be available in the savings account. But then we are now coming to make use of that method. So how is that possible? Because we may end up, if we are just in a loop, we may end up calling a method that is not in that particular class. So this is why we need to check, is it an instance of? Because remember that we said we are trying to enjoy the advantage of polymorphism to represent that object in many forms, that is to say in its own class, and also any class that is on the top of that subclass in the class hierarchy we are trying to now represent. So maybe I will give an example for better understanding. So this is the way. Now, so basically, we said the circle is of type circle and also is of type rectangle, and a rectangle is of type shape. Likewise, circle is of type circle and also is of type shape. Now, coming here, if you can recall the shape program we have written earlier. Now, this is just a test class where we implement the concept of polymorphisms. Now, if you look at this, here we are creating an array of shapes, which is 3 elements of shapes, 3 basic shapes we are trying to create here now. And remember, shape is an abstract class, and therefore we cannot instantiate an abstract class. If we can create an abstract class, that means this should be written as what? With shape, and then this should not be a square bracket, should be a parenthesis. That's to say is an instance of shape. But what we are creating here is just an array of shapes. That's to say can only contain 3 elements. That is 3 basic shapes that we can store into the array of shape. Now here we assign, we say shape 0. Remember the type is shape, but now we are representing a circle, a rectangle in form of shape, and we are representing square in form of shape, and we are representing also circle in form of shape, because we know that circle is a shape, square is a shape, rectangle is a shape. So this way. Now, if you look at the type of shape here, this with small s is of type shape. The type of it is shape. And what we have on the right hand side is of type rectangle, square, and circle. And this is exactly what you are seeing now. We are assigning to shape 0. Shape 0 means the first element in that array, is indexed at 0. So shape 0, the first element in the array, will be an instance of the rectangle with dimension 5, 10, which is the length and the width of the rectangle. Then coming here, the second element, shape 1, and we are storing a square. Shape 2, we're having a circle. Now, the next is to look through all these elements, the 3 elements we have here. The 3 elements we have here can be written can be assessed in this way. We set up a loop from the first element, because you can't start from 1. If you start from 1, that means you are jumping the first element at index 0. So you start from index 0, which I'm sure you know this in 2 and 1. And then we loop through until we get to the shape.length. And shape.length, what should be the value of shape.length here? Who can respond? If I say shape.length, what is the value of that? Yes, can somebody respond, please? Shape.length. What is the value of shape.length? Okay. So shape.length is the number of elements in the array. In this case, we have 3. So if we say I less than shape.length and the length is 3, that is to say I will stop where? It's going to stop at 2. And this is the increment. So this will start from 0 through 2. And the increment is 1, 1. So we come here, we now say system.out.println shape I.name. This will give us the name of the shape. Remember in our shape program, I think I demonstrated this. We did this, we have written this program and the same program we are referring, only that we are modifying the test class where we can enjoy the concept of polymorphism. And here we say shape I.perimeter. We are calling the perimeter of the shape. Shape I.area, we are calling the area of the shape. Now, in this case, if you look at this, shape I.length, we are calling the name of the shape. Which shape? At this point, we don't know which shape. But all that, we have rectangle, square, and circle. Now, if I is 0, that is to say we are calling the first shape, which is what? Rectangle. So it will give us the name and perimeter and area of the rectangle, which is this. Now, the next iteration will be I++, which is increment by 1. I becomes 1. And in that case, the value of I will be incremented by 1 and becomes 2. So it becomes 1. Thus, the shape at index 1 is square. So if shape at index 1 is square, then also the name will be retrieved, which is the square, which is the name of the class, the perimeter of the shape, which is this shape I, which is shape1.perimeter, shape1.area. Also, this will retrieve the area of the square. Similarly for circle, which is at index 2. And when I increment by 1 becomes 3, this becomes false because 3 cannot be less than 3. So we said the application creates each type of shape and print its properties. And this are the properties now. The rectangle, perimeter, and area for the 3 shapes we have created. And so first we note that because the references of type shape in the array shape are polymorphic, we are able to store all the 3 types of shapes in one array. This is one good advantage. In one array, we're able to store all the 3 rather than to create a memory space where we can store each and individual shape. But now with one array, we'll be able to store all the shapes we have. And this is the polymorphic concept. Because if you look at how many different shapes we have created, we have circle, square, and rectangle. And all of them represented in form of what? Represented in form of shape. So if we can represent in form of shape, it means each of the shapes we created can be represented in form of itself. That is to say, we can say a circle, R equals to new circle, something like that. Also, we can do the same for rectangle. We can create an instance of the rectangle. We know it's of type rectangle strictly. And it's also square. But now we have enjoying the concept of polymorphisms by creating different kind of shapes and all store them in one single array. And with the kind of one single loop, we can have everything created. So even if we have 1,000 instances, at least we can look through to assess them with their properties. So this is basically what it is. Now, then the idea, remember that even in the abstract classes, the one we have written earlier, where we created abstract methods in the shape class, you know, they are abstract, the perimeter and area are abstract methods, which they do not have implementation in the shape class because they are incomplete. We don't know the area of the shape we're going to calculate or we're going to return. So in that case, we decided to make it abstract. And because of those two methods that are abstract, we have to declare our shape class to be abstract. Fine. Then in that same class, if you could recall, we had toString method that returns the area and perimeter of the square. So of all the shapes we created. But the toString method is in the shape abstract class. What will happen if that area and perimeter values are not associated? And remember that they are abstract. They are not even complete in the shape class. But then we are calling those area and perimeter in the shape class, even though they are not being implemented. So how is that possible? We said it's possible because Java supports what we call late binding. Late binding, not early binding. Or we call it late binding or dynamic binding or runtime binding. Either of the two we call it. So there are many compilers that do support early binding, that is static binding, or dynamic binding, or we call it running time binding, or late binding. Anyone you call, any of the three names you call, it means the same. So because Java supports that late binding of a thing, so the association of a method to a particular method is called binding. This is what we mean by binding. Whenever we say binding, we mean association of a method called to a particular method is called binding. So meaning that I have a method area now, and I have a call area. At what point will I now associate which of the method am I appropriately calling? It's not at the compile time, but it's at the running time. At the running time, by then, that method must have been implemented. Meaning the subclass that is going to extend the abstract superclass must have implemented the abstract method. So since that method has already been implemented, then calling that method at the runtime will not cause trouble. But if it is at the compile time and you are now trying to call a method that has not been implemented, and you call a method that is not even complete, then that is going to cause error. And because of this advantage that we have over the use of dynamic binding of Java, then it is possible that we can have the method called in the superclass that is an abstract, and any method that is a subclass of that class will implement the abstract method of the superclass. Then at the running time, that is whenever you make a call to that abstract method, it will try to associate which method should it be bound to. So is it going to now associate with the method of the superclass or method of the subclass? Because if it is a method of the subclass, yes, by then it must have been implemented and it has been, at least the methods must have returned an appropriate value, unless if that also the child class is an abstract class and therefore does not implement the abstract method of its own superclass, then another subclass that is a subclass of that subclass can now implement the method. So again, that will not cause trouble because of the advantage of late binding. It's still going to now associate the method call with the method of the subclass. I hope guys I'm communicating. Okay. So yes, we can. The idea behind this late binding of a thing, Java supports this late binding, but whenever the method is final, there is no way you can have a final method. Final methods normally associate at the point of compilation, not running time. Remember, why we say final, any value associated to a final method or final, you know, from the word final, it means once assigned, it can never change. So if it cannot be changed, then that becomes what? Constant. And that is what we now declare that method as what? So declare that variable as final. If it is a method whenever we have method as final, meaning that that method cannot be overridden. Cannot be overridden. You should understand that, meaning it cannot be overridden. So if we have a class, you should understand this critically. If class is final, what does that mean? If class is final, what does that mean? Can somebody respond? If class is final, means what?
So we cannot bind anything, or we cannot run any length.
So a class that is final, meaning it cannot be subclassed. Any class that is final, meaning it cannot be subclassed, meaning that class cannot have a child class. So if a class A is final, if I say public final class A, meaning that class cannot have a child. So I cannot say B extend A because A is final, meaning it cannot have a child. Just like maybe having to say, oh, this is a parent and this parent cannot have a child. So if any parent cannot have child, then you can now make that class to be what? Final. Yes. So if we have a class that is final, meaning it cannot be subclassed, meaning it cannot be extended. This is what you mean by final. So if class cannot be extended, that means there is nothing bad if at the point of compilation there is an association. When I say association, I mean what I mean, binding the method call with the method declaration. So this is it. So since it's final, meaning it cannot, if method is final, meaning it cannot be overridden. So if a class has a final method, a child class cannot go and override that method. So if it cannot be override that method, is it appropriate to say to have an abstract method that is final? Hello? A very good question. Is it appropriate to have a final abstract method?
Yes, sir, since the class will not have a child.
No, forget it. Now we're not talking about the final method. A class is not final. Now, of course, if it is final, then it means if it is final, then is it logical to even have an abstract method in a final class?
No, sir.
No, thank you. So if the class is final, it means it cannot be subclass. And how can a class that is not even complete and said, oh, no child class will now come and complete that program or that method? It's not logical. Since the class is final, it means it cannot be subclass. And if it cannot be subclass, that means it shouldn't even make any method to be abstract. That's it. Because it's not logical to have a class that is final but then contain an abstract method. No. So now the question is, if class is not final, that is not declared to be final, fine, and then it's an abstract method, can we have method that is final in the abstract method? Hello, I hope you get my question. Okay, so I will post this on discussion forum. I want us to discuss about this. So I will note it immediately. I will post it, but avoid copy and paste. Yes, go and read. I'm not saying this should just come from your. If you know, you know. If you don't know, you don't know. But all that, please read. When you read, don't just go and copy and paste. No, read, understand, then put it in your own words. Explain clearly. But then this should be demonstrated with an example. So when you mention yes, it's possible that we can have a final abstract method in the abstract class, then support with your answer, either yes or no. If it is yes, we can have a final abstract method, or we cannot have a final abstract method. Remember, if we say final, it means it cannot be overridden. And then you have the final keyword, which cannot be overridden. But then remember that the method is what? Abstract. And if it is abstract, any class that is going to now extend that class must implement the abstract method. But now you are saying the implementation means is overriding. But now you are saying is final, which you are now restricting that method to be overriding. Is that possible? If yes, why? If no, why? Demonstrate with discussion and example. So I'm going to post that in something. And again, it's good that you go when you do it and when you discover that it is yes or it is no. Write the program, that example, try to compile and run it and see whether it is possible or not. Then understand why it's not possible, why it's possible. So that way. So what advantage can we have over this polymorphism? Since binding takes place at runtime, it is possible to make a call to abstract methods. So this is what I've explained. Because of the advantage of late binding, we can call the method of the abstract class. And similarly, in the shape where we have the area and perimeter, and this is exactly what I did last, where I have the area and perimeter in the shape class, and they are all abstract. And we have toString methods, which is now returning the perimeter and the area. And perimeter of the area of the shape, we don't know until we go to that specific shape, being a circle or rectangle or square or rectangle or whatever, then we can now know the area and perimeter. So what will happen? If it is at the compilation time, then whenever this call perimeter will be associated with this method declaration. But this is not complete. So how will this going to bring its own value and assign to or associated with this? This is why it is not possible if it is an early binding. Binding, like I said, let me repeat, is associating. It's just like mapping this perimeter with this perimeter. This is method call and this is method declaration. So how will the compiler know that is the perimeter, this perimeter that is now going to be associated with this or another perimeter that is somewhere? If it is at the early binding, that means this will be associated with this. And this is not complete. It's abstract. We don't know what is that perimeter. So if we don't know the perimeter and we are trying to associate a call to an unknown something, that will lead to an error. But if it is the late binding, that is at the compilation, at the running time, by then the perimeter and area of the subclasses that implemented the shape, that implemented the abstract methods, area and perimeter, then at that point in time, the association can be established, and that there will be no any error. So this is the same as the previous one. As you can see here, advantage of it, there we had, in each iteration, we have what? 3 lines. In the previous examples, we have 3 lines in every iteration. But in this iteration, we have just 1 line. And why, from where this is coming is the same thing, like if we refer to our previous example, we have seen this, I think, where we have toString methods. And here in the system.out, in the where we are looping over the elements of the shape, we have system.out.println with just 1 line printing the area and perimeter of the shape. By calling the shape I, we now call toString method of the superclass, which is that toString that returns the area, perimeter, and rectangle, along with the name of the shape itself. So this print called the toString method of the object, since the method is not overriding in the subclasses, that of the superclass is used. So you see now. So if the method toString has not been overriding, then the method of the superclass will be used. But if the subclasses override the method of the superclass, and you call toString method here, it is the method of the subclass that will be called, not the method of the superclass. So in that case, that means there is nothing bad if we have area and perimeter in the superclass called, because whenever we have a call to area and perimeter, it is the area and perimeter of the subclasses that will be called, not the area and perimeter of the superclass. So in that case, the values of the area and perimeter must have been ready by then. So, and that will not lead to an error. Now, due to polymorphisms, the call to perimeter and area method into stream method will be bound to those of the actual object. This is it, because it's delete binding. And the area and perimeter have been overridden by the subclasses. So it is not the method of the superclass that will be now used, but rather the method of the subclasses, based on looking at this example. Because remember, we said since toString method has not been overridden, then it is the method of the superclass that will now be used. Yes. But if there is an overriding method, then unless if the subclass also called the toString method of the superclass, remember the one I think I gave an example with, I added with that of super.toString to call the string method of the superclass. So at that point in time, remember, we still have area and perimeter implemented in the subclasses, and the area and perimeter will now be associated or will now be bound to the methods call of the superclass that we have in the toString method. Now, so if we can enjoy this, remember, it's just like having rice and beans mixed together, and we are now coming to assess to differentiate between the rice and the beans. And let's say now there are some properties in the rice and some properties in the beans, and we are trying to separate to now get a property of a beans. And we know that property of beans is not available in the rice. And we have a mixture of everything. And we are saying, okay, get properties. And we know only, suppose only beans has a property and rice doesn't have. And you mix them together and you just begin to say, get properties. Use the object of all to say get properties. Then by the time it has discovered one instance of beans, so the instance of rice, then you are going to have an issue, because there is no way, and that method of get property is not available in the rice class. So that will lead to an error. In that case, what do we need to do? Or when you have a subclass and you have a superclass, and it happens that, remember, the type is of the superclass. Remember, even the shape is of type superclass. And if the method does not exist in the superclass and you're trying to call a method that is tied to only subclass, what is going to happen at that moment? So this is why we need to downcast to convert it from the type of the superclass to the type of the subclass in order to proceed. So in this case, we have seen that an object of a subclass can be assigned to a reference variable of type superclass, and we have seen this. This is the upcasting automatically, because by the time we have assigned an object of a subclass to a reference variable of the superclass, then this is automatically upcasting, because we have converted a type of the subclass to a type of the superclass. Remember where we say shape equals to new rectangle. That new rectangle, we are saying an instance or an object of a subclass rectangle is assigned to a reference of type superclass shape. That is automatically upcasting, because we have changed the type from the subclass to a type of the superclass. But then there is a situation whereby we still need to reverse back to that subclass. What is going to happen? It said the natural question to ask is, does Java allow the reverse? Yes. Does it allow the reverse? Because automatically you have converted from a subclass to a superclass. So can Java allow the reverse to, that is to move from the superclass to a subclass? Is that possible? Now, assigning an object of a superclass to a reference type of subclass called downcasting can also be done. but it is considered to be a narrowing conversion and must be done with a cast. So we have to cast it. So we can't just make a reference of something to assign, or an object of something to assign to a reference of the superclass, like the way we have done in upcasting. So in this case, we have to cast it with this keyword cast. So we wrap it in the bracket and then we convert it. So that is the reverse. We convert from subclass to superclass, and then from that superclass to convert it back to its own subclass, we then cast. So this is what this one is saying. We know a faculty member is an employee. Fine. So we see now an object of type what? Faculty is assigned to an object or a reference. This is the reference of type employee. That's fine. We're only saying that a faculty member is an employee. That's fine. Then, if a faculty member is an employee, that's all. And then, is it possible to now come here and say, okay, this now employee is of type faculty? This will lead to an error because this does not allow, if we have converted an object of type subclass to an object of type superclass, and to reverse, it's not just possible to assign, to take this object and assign to a faculty. No, if we are to do that, we have to wrap it in the bracket by using this to say, okay, this EM, that is an employee, is converted to a faculty member. And that's all. So this, of course, what we have here is of type faculty, and what we have here is of type faculty. So we can make use of this faculty to call the method that is only tied to or only available in the faculty class. And why do we need to then cast? Why? If we have upcasted an object to of type superclass, why do we need to then cast it to an object of type subclass again? Remember, we are to achieve the concept of polymorphisms. By the time we did that polymorphic way, automatically we know we have converted an object of subclasses to an object of the superclasses. But then there are situations whereby the method we want to access, an object of the superclass cannot inherit the method of the subclass. What is going to happen in that moment? So we have to reverse it back. And to reverse it back, of course, we know, even to reverse back, we don't know which one are we. Are we currently assessing a method or a class that method which we are interested in calling is available or not? We don't know, because we know we have a mixture of all different kind of instances that of different classes, only that they belong to a superclass, and we are trying to achieve to take advantage of the polymorphic way of representing this object. But then we still want to reverse it back in order to access a particular method of the subclass. So in fact, downcasting is only advisable if the object being downcast is actually of the subclass type. So we have to make sure that is of type, the subclass type. That is this one. If it is not this, then again, this will lead to an error. So which was upcast to the superclass and now being downcast back to the subclass, like this one now. Faculty is assigned to a reference of type employee. And we said, is it possible now to reverse it back to say, okay, this is an employee, this is a faculty, which is a subclass, and now bring the superclass type and assign to this? We say no, this will lead to an error. And the way to handle that is by wrapping this in the name of the method, so the name of the class, so that the left and the right hand side should have the same type, faculty, faculty. That way. Now, a good question now is, why will it be necessary to go through this cycle of upcasting and downcasting? Why? I think I've explained this. Why do we need to go and do all this possible way of too much iteration, upcasting and downcasting. Now, a good example, we take a vector here, which I'm sure you must have done this in 2-1 vector. A vector is more rugged. It has better advantage, especially in terms of in form of a container where it can accommodate a number of objects and it can dynamically be increased once it is exhausted, unlike an array whereby prior to the accessing of that array, we must declare the number of elements that an array will store. But in the case of vector, we can have an advantage by creating this by creating any number, and once the number is exhausted, then automatically it will double that number. So let's say now we have 3 elements. As you can see here, line 4 is declaring a vector here that is to store 3 different kind of shapes. But if we have the 4th one added, then it's going to now, by the time we attempt to add, instead of it to say no, the container is full, then it will look at what is the current size is 3. It will double that size. So it becomes, the capacity becomes now 6 rather than 3. It will double with that capacity. So unlike an array, once you have exhausted, you have exhausted. You cannot increase the size of an array. So that is the disadvantage of an array. Though there are some dynamic arrays like array list, vector, and some other kind of different array something. So those ones are flexible and good enough, especially when you are dealing with this kind of dynamic of a thing. But an array is fixed. It's fixed, unless if we are now going to tell user to give the size of elements he wants to create, and based on that you now send it and say create an object, because an array also is an object. So you can create, instantiate, and then pass the initial value, and then, but at the point where you have initiated that, you cannot dynamically increase the size of that array unless you stop it and go back and now start again. Ask user to enter the capacity or the number of elements to create that way. But in the case of dynamic array, you can now have to say, okay, please enter the number of elements you want, or enter the number of the capacity of the container, or whatever you want to ask the user to enter. Okay, by the time user entered that value, if the array is exhausted, that is the capacity of that container is exhausted, then you can dynamically tell user to say, okay, now there is no more capacity left for this container. Do you want to increase? If he says yes, fine, let him specify yes. If yes, then again enter another element, another number, in order to be the new value of the container. Then you now go and increase. So in that case, in fact, you don't even need to ask the user. You can continue, because vector allows this possibility, unless you feel that, okay, this is the value and this should be the increment. You can specify. Yes, another good example. Remember, we did talk about when someone asks, why do we need to have this method overloading and method overriding or constructor overloading and things like that. Now, if I want to specify a vector and I'll say, okay, the first value of the vector here as a constructor will specify the size of the vector, the size of the container. But then, since it's dynamic, and by the time this 3 is exhausted, automatically it will double that value. So it becomes, the capacity becomes 6 dynamically, automatically. It will make it to be what, 6. And if that 6 is exhausted, it becomes what, 12. If 12 is exhausted, it becomes 36. And probably I may look at, oh, from there now, the value is doubling. And it's going to now occupy much more space. So with that, is that what I want? I say, okay, fine. No, maybe the doubling is too much for me, but I want it to be like, let's say the increments, once it is 3, the next one should be 6, the next one should be 9, rather than from 6 to 12. Now I'm adding 3 as a step increment. So first it will be 3. If 3 is exhausted, it becomes 6. That is 3 times 2 if the increment, the step is 2, 2. So if the step is 3, 3, so it becomes first is 3, next becomes 6, next becomes 9, next becomes 12, next becomes 15, next becomes 18, next 21, like that, increment of 3, 3. But now, if you allow it to go by the default, if you specify the first parameter value, then if 3 is exhausted, it becomes what? Double. That becomes 9. 3 times 3, 9. If that 9 is exhausted, it becomes, double. I say double, not square. If 3 is exhausted, it becomes 6. If 6 is exhausted, it becomes 12. If 12 is exhausted, it becomes 24. If 12 is exhausted, it becomes what? 24, then 48. So if you look at the rate at which the number is increasing, it's not the same as if the step is just 2, 2. So 2, 2 means it will be adding 2. So when, if it is 3, 3, to be adding 3, 3. From 3, next will be 6, next will be 9, next will be 12, next will be 15. Like that. So you can have a control of that increment if you don't want to make use of the default. Now, there is one method called add, and this add is in the vector class. It's a method. And remember, this vector is a class that is not a user-defined class. It's in java.util package. Yes, it's in java.util package. So shape.add, we are now calling the add method. And add method is in the vector class. And we are saying that we are creating a vector of shapes. So how do we now add? Remember, it's not an array. If it is an array, we say shape I 0 or shape 0 equals to something. But now it's a vector. And if we are to add any element in the vector, we have to make use of the add. Please take note of this, because by the time we start GUI, graphical user interface, where we create an interface, all the program we have written will interact with command line, or we click on a button to run. But rather, later we're going to now create an interface whereby the program we have written, the same program that we have been writing for all this while, you create an interface where you can even ask the user to enter the value from there. Maybe I want to withdraw, then you provide me with an amount to top up my wallet. Then you now say, please enter the amount to top on to your wallet. Then I click on, I enter the amount, click on, then it adds to my wallet and things like that. But this one now, the one we have been using is probably just go to command line, or we see the result, oh, please enter the amount, then enter the amount, press enter, then something will occur. So in that case, there should be a button that will trigger the event of sending the amount to credit your wallet and things like that. Or you want to withdraw, then you see a text box, enter the amount to withdraw. You click on the button withdraw, you withdraw. Or you provide a user with a radio button. You want to withdraw or you want to deposit. If the user selects withdraw, then a withdraw transaction should be performed. If it is a deposit transaction should be performed, or whatever the case, or check your balance, you check your balance at that moment, all through the user interface interaction. So add method will now add the rectangle, add square, add circle, all in the shape vector. Now, here we print out. Remember that this shape that we are creating, as far as this is concerned, is of type vector, not of type shape. Remember that. Is of type vector, not of type shape. Is it? So now we come here and we now assign another instance, rectangle, square, and circle, into the vector. And remember, a rectangle already we know is a shape, circle is a shape, square is a shape. Now they are of type vector again. So here you are now. So we look through. We say for I0 to I less than shape dot size. So if you want to know the size of the vector, you make use of the size, not length. The length is for the array. But if you want to know the capacity of a vector container, you make use of the size. Then I++, which is going to increment by 1. So it's to start from I up to 2, increments of 1, 1. Then here we said next chef equals to chef.get I. Fine. A very good example. Now, next chef, remember the chef we are trying to get is of type vector. But now we are saying it's of type what? Chef. Will that lead to an error? Yes, it will lead to an error. It will lead to an error because the chef here we have is of type vector. So when we say chef.get I, that means get I when I is 0. I 0 means what? Rectangle. Get is to get the rectangle now, which is I equals to 0, the first iteration. I equals to 0. So if I say chef.get I is going to now return this reference for me. This reference. And this reference, remember, is of type what? Rectangle. Meanwhile, at this point in time, you have casted this rectangle to be of type shape. So you have cast takes the rectangle to be of type shape. But now we want to change it back to something. So here we are now. We say shape.get I. So this shape.get I is now of type what? A shape, but shape is converted to what? A vector. So the shape is of type vector. If shape is of type vector, can we now assign shape that is of type vector to another class that is of type, or another object that is of type shape? No. So this is where it is necessary we have to cast it here by wrapping this in a shape. So once we have this as of type shape, then that's enough. So we can say next shape, then we can call all those methods, name and the area, as the case may be. Without this, then this will lead to an error. Maybe we make use of the last 30 minutes to demonstrate an example. We can bring out that program that we have written and try to manipulate and see the reason that we are discussing about. So it's good to understand, take notes. You see, this is why I'm moving slowly. I really want you to get this, unless if I'm just maybe alone in the class making noise. But you should pay attention to understand precisely what you are trying to do. Now, there are some situations whereby I said we have a mixture of all these, but now we are trying to separate them. We are trying to separate them. Is there a way in which we can separate all these elements? Let's say now I ask you, how many cycles do we have in the program? We have a mixture of cycle and rectangle. And I say, how many cycles do we have? Or let's say, for instance, like we have the way we have this. We have radius, get radius, and the radius is not available in the rectangle and it's not available in the square. We know radius is only associated to what? Cycle. And if I'm in the loop and I want to return the radius, how will I return the radius? If I'm in the instance of rectangle and I say get radius, it's going to lead to an error because there is no get radius in the rectangle. And there is no get radius in the square if I just allow it to go in that loop. Remember, we are in the loop and we don't know whether in the first iteration or second, you don't have control. Whether it's in the first iteration or second iteration that you have cycle that you can now see, okay, when it has reached this certain iteration, it should get a radius. You don't have control. You don't know the order in which they will come. So if you don't know the order in which they will come and you are trying to assess radius and the radius is not available in the square and it's not available in the rectangle, then what do? Then this is one good advantage. You now make use of this instance of. This instance of will allow us to even separate an object. Let's say, for instance, you have different type of account mixed together and you want to now count how many that are savings account, how many that are current account. You want to clearly separate in your program. You want to separate between this. What do we do now? In that case, it's as simple as that. You just say instance of. That is to say, if the next chef that we have is an instance of cycle, if it's an instance of cycle, then is that again still enough to make use of the next chef and the next step is of type chef? If we make use of the next shape that is of type shape and we say get radius, will the radius available in the shape class? No. We have to also downcast it to what? To circle. So this is why we call the circle here. Why don't we need to downcast this to a circle or rectangle before we call the name and the area? Remember of the advantage of the lead binding in the Java application, because we have the method already that are abstract, name, sorry, area and perimeter that are available in the shape class. Only that since it is supporting lead binding and there is an overriding by the subclasses, then there will be no problem. But in the case whereby only the radius, and we know radius is only available in the subclass, what do we do? This is the way we can avoid falling into an error, by using the instance of method, this keyword, instance of. So it's now saying, is the next shape an instance, meaning it's an object of cycle? If it is an object of cycle, then cast that to cycle and give us the radius. So you have to then cast it to a circle, because if we make use of the next shape, and next shape is of type shape, and there is no get radius in the shape class, then that will lead to an error. And this is clear, please. This is why whenever you are to listen, you listen with your mind. Don't just listen with your ears. Listen with your mind, and that you will understand. Because if you are just listening, believe me, and again, it's not just, even if you can listen, one thing you have to understand here, you have to understand the previous lectures, because if you miss abstract classes, all those inheritance of a thing, then believe me, you will not even understand polymorphisms here. You just sit down as if we are just speaking one branch like that. So, and this is an idea. It's not a news reading or something. It's a knowledge we are trying to pass here. So you need to pay attention, understand the intricacies here, so that at least by looking at any problem, you'll be able to look at it in object-oriented way, and you can make use of all these abstract classes, interfaces, and even this polymorphism of a thing. And you know, nobody will need to tell you that, okay, by the time you get to this, you need to do this. At least you must have learned that. And this is obvious. You are trying to get something that you don't have. Suppose you have a child, and your child is set to inherit you, and you as a parent, you cannot inherit your child. Now, if your child can inherit you, then we say a child is a child, and a child is a child of his parent. That means a child is of type child and also is of type parent, because it's a child of the parent. But a parent is of type parent but is not of type child, because a parent cannot inherit child. Now, fine. So we represent a child in form of parents. Fine. Like we say parents, P equals to new child. You see, we're assigning a child object to a reference of type parent. Fine, that one is okay. Now, if there is a method in the parent class, we know a child can call that method because of the inheritance. Okay, fine. Now, the fact that the parent cannot inherit child, if a child has a method, the parent cannot call it, because it's not for him. It's only a child who has the right to call the method of the superclass. But parent cannot call the method of the subclass. So for the parents to call the method of the super, if we are using an object of type parents, we have to then cast it to a method, of type child class before we call that method of the child class, because the parent cannot use it. So we have to then cast it to a type of the child class. So this is typically the idea. Once you can recall that, oh, a child cannot inherit parent, that's all. So if a child cannot inherit, if parent cannot inherit child, if we have casted an object of type child class to be of type parent class, and when you are to assess a method of the child class, you have to then cast that to a child object. Otherwise, you cannot. So this is typically what we are doing now. The radius is in the circle, which is the child of the shape. So if we have already casted the cycle to be of type shape, and now we have a type of type shape, and we now want to get the radius, and the radius is not available in the shape, but rather is available in the cycle. So what do? We then cast that shape to of type cycle, and then we call the radius. This is typical what we are doing now. And this is simple and straightforward. So if you understand this, then there will be no any issue. There is nothing like story here. Even if we have never gone to learn Java and somebody explained this concept to you, you will be able to understand that, oh, okay, since the idea is saying that a child cannot inherit parent, sorry, a parent cannot inherit child, but a child can inherit parent. So the child can call all methods that are accessible to him, remember, accessible to him, because the parent can also deny the child by making those to be private or protect, sorry, private. If they are private, it means only properties of the parent. A child cannot access or inherit the private properties of the parent. Yes, any private properties of parent cannot be inherited by the child class. But if they are accessible, this is why now if we declare variables to be of type private, but most of the method will make them to be what? Public. But again, if they are private, they are being denied to be accessible by the child class. So even the private method cannot be accessed by the child class. But all public methods or public variables can be accessed, even though that's why, because of that security, we said we don't allow variables to be of type public. If you allow them to be of type public, then they are porous. They can be changed at any point in time. So, but if we have, this is why we have advantage of having these accessors and mutators. The accessors will try and get or retrieve the value of the instance variable from where it is being stored, that is from the memory, retrieve the value, only the value, and return. But the memory space is still there. The child cannot have access to the memory space because the memory space is private, and the method will just go and return the value. It's just like now, okay, you ask me to give you money, and I say, okay, this is where I keep the money. Please go and take it. That means if I say this is where, it means it is not private. It is not only me who have access to that. I've given you guarantee that, okay, this is where I keep the money. Please go and take it. That means tomorrow, even if without any instruction, you can go and pick it and use it because I'm giving you access. It's not private. But if I have a method to say, okay, I will have a method that will go and retrieve the money without telling you this is where the money is, then the money will be retrieved and you'll be given that money. Where it is being kept, you don't know. This is the advantage of the assessors and mutators. The assessors will allow us to retrieve the value of the private value, that is private memory space, that is private, and retrieve the value and issue it to any class that is trying to access that value. But having a memory space, access to the memory space is being denied by the private access modifier. So that way, and for the mutator, where we need to change, we only say, okay, give me the value. I will change without you knowing where it is. So just give me the value of the one you want to change with. Then if you give me, then I will change it. Then I will keep it. But if I say, okay, please go and change it, it means I'm giving you access to the memory space that you can even go and have access to the memory location. Remember, when I say memory location, just like a room where I keep the money. So you go to the room, change the money of your choice, increase, that is add the money or take out money or take in money, whatever kind. You are changing, you are having access. But this one, I say, no, I'm not going to give you access to change or to get, but rather tell me what you want. If you want the money, I will go there, I will pick it, and I will bring it to you. That is through the getter. Now, you want to take in money there, give me the money, I will take it myself, I will go and keep it there. So you will not have access direct to it. This is the accessor and mutator method of a thing. And you see, that is secured, then allowing you to have access direct. Allowing you to have access direct, then, you know, all depends on where it is coming from. I hope guys I'm communicating. I hope I'm not just making noise in the class. Hello? Okay, great. So I think it's enough all this explanation of casting and casting. I've explained them enough. Uh, Similarly, if we have, yes, another good example, I think I should talk about this. Remember we talk about different kind of employee. We said monthly employee, hourly employee, commission employee. And now the employee that is worked based on an hour, that is hourly employee, will have a method, add hours. And we know add hours only applicable to monthly employee. And if we just randomly call add hours, it means well, there is possible that, okay, that method add hours will be added to monthly employee, and monthly employee is not entitled for, or it doesn't have a method add hours, or add hours doesn't apply to monthly employee. But we are randomly just calling or iteratively calling the add methods hours, add hours to all different kind of employees. Remember, we are in the polymorphic because we are representing objects to be of type, that object and also to be of type its own superclass, because we are mixing everything together. So we don't know which one is which because of that advantage of polymorphic. But now we want to call method add to apply to one type of class. And already we have a mix of classes, so we don't know. So we now make use of instance of here. We now say if an employee is an instance of hourly employee, that means this employee is a member or is of type hourly employee or is an hourly employee, then add hours to him. But is that appropriate to say add hours to him? Because already here that person is of type employee and add hours is not a method of the employee class. So we have to then cast it first, and then we call the add hours to add the hours. Or otherwise, if we say hourly employee it is equals to, then we now say imp1 dot add hours trouble. Yes, because the method add hours is not in the employee class. And remember, the employee class is the parent class. Like I said, the method is not, because the parent cannot inherit the child. Therefore, the employee cannot call add hours, cannot. But if it is a method of the super class, the subclass can call that method because he can inherit, unless if it is private. Guys, I've said a lot about this, I think. So, advantages of polymorphism. To conclude, we take a quick look at the advantages of polymorphisms. One, generic code. Polymorphisms allow us to write code that can be applied to different types of objects and get different results based on the object. Yes, different results based on the object. It depends on the objects of which class, you see. So it's more of a generic code. You write a one generic code without writing or repetition of many things. You write one single code, but it's more of like a generic way. And with that, you can you can call all methods of different objects of different classes. So there is no need to write separate code for each type. So we just put everything together, and that's all. With the use of this instance of, we can separate. Now, extensibility, it allows the functionality of the code to be extended. So once you have that, remember, even if we are going to now create another subclass. By creating that subclass, all you need to do in the subclass is you just go and add that method also, and add the instances of the new added class. Let's say, for instance, we add a triangle in the shape class. So if we add the triangle in the shape class, while we are instantiating, where we have the radius, where we have the circle, rectangle, and the square, all we need to do, we just go there, add a triangle. That's all. This is what it's saying. So then the same code in our application can be used to process triangle shapes as well. We don't need to do anything. All we just write the class triangle. a subclass of shelf. Fine. Do implement the area and perimeter, because the area and perimeter are abstract method in the shape class. So once that triangle override the method, fine. Unless if the triangle itself is an abstract class, which doesn't need to override the abstract method of the shape class, fine. Whatever it is, when we come to implement the functionality of that class that we recently added, we go to our test class where we have the polymorphic way. That is where we have the rectangle, square, and whatever. So we now add a triangle. The same loop that now assess all or iterate over all the elements of that array of or vector of shapes. The same thing, we don't need to do anything there, unless if we want to filter out some properties that are only associated to triangle. Then we use the instance of method to say that, oh, if this is an instance of triangle, then give me this. Suppose the triangle we are interested in, it depends on the kind of triangle. We may have a half base times height, or you may have the formula for finding the area of triangle. S into S, S minus A, S minus B, S minus C, like that, where S is the same as A plus B plus C over 2. Think, this is the formula. So, whatever, if you get that, if you really want to get maybe the base, let's say the formula for the area is base times height, and you want to get the base of the triangle. And base is not applicable in the circle, it's not applicable in the rectangle, it's not applicable in the square, and you are interested in getting the base. So you have to check, is this object an instance of triangle? If yes, then get the base. Or otherwise, in the loop, if you say get base, and when it has reached to cycle and there is no base in the cycle, then the program will crash. So that is to say, you're going to have an error there. So you have to check. If it is an instance of triangle, then get the base. Already we know we have a getter that will get us the base of the triangle, and also probably the height where it is necessary. So I think I've said a lot about this. Then this will increase also readability. Apart from the flexibility, apart from the generic code, flexibility, now readability. This will help in making our program to be more readable, more precise, more generic, more flexible. Like for this one now, shape I, where it will bring the area perimeter of all different shapes you have, being a rectangle, triangle, or even any kind of shape we have. So rather than to write this, where we say we have to say area, perimeter, or we have to come here and say switch, then if the type, shape type I, then if it is an instance of this or this, then we'll do this. So this is quite tedious and is complex as compared to just write this. This is more precise, more readable than this. Because if it is this one, you have to say switch, and if this is of type this, then do this, and if you get that, then break. And it's complex. Okay, so this is another more exercises which I'm going to bring later and add it off with that previous one. Making sure I wanted to send that one, but I'm unable to send it. But I'm going to combine these two together, this one and last one. Now, I was thinking by now we must have done with packages, but let's move with the speed of light. In the next 21 minutes, we should cover this. Now, what is package? Why do we use package? I think I should not spend more than 10 minutes on this, because already I've explained what is package. You just need to see that a package is a group of related classes, interfaces, group of classes and interfaces. Just like the way we organize file structure in our documents, in our Windows or in our computer. Why do we need to have a folder called documents? And inside document, why do we need to have a folder called pictures? Why do we need to have a folder called videos? Why do we need to have a folder called audios or something like, or music, something like that? Why do we need to have this because of organization. We make it more organized. But if you have a folder that contains pictures and audios and videos all mixed together, when you are looking for something, you find it difficult to even trace it. It's difficult to trace it. So, but when you organize your files, that will be better. Will have a better look than having everything put together in a single directory. So whenever we have a package, we mean creates a group whereby related classes or interfaces will be together. So why do we use these packages? Why do we need to have this package organization? Of course, to avoid conflict, we can make use of the package. Suppose, for instance, I have a student, or let me say, let me give an example. Let's say we have a student from university, and I have student from, let's say, BUK, and I have a student from UNILAG. Now, the word student is a class. The word student is a class. And I have two different classes. One class is for BUK, and another class is for UNILAG. Okay. Now, if I call students, which student am I calling? Can somebody respond? If I say student, which student are we referring to? Are we referring to student of BK or student of UNILAG? Both of them. So that means if both of them, that means there's a conflict, obviously, and there's no way you can refer to two of the students of the two different classes. I have to be specifically addressing one student, either from BUK or from UNILAG. So that is a conflict now. There is a conflict because student of BUK or student of UNILAG, we don't know. But now, if we have a package, or to create anything associated to BUK, we create a package called BUK. Anything UNILAG, we create a package called UNILAG. So if I say BUK.students, which student are we referring to now? Student of BUK, not student of UNILAG. If I say UNILAG.student, it means I'm referring to student of what? UNILAG, not student of BUK. So in that case, I must have differentiated between the students I'm referring to, either student of the BUK or student of UNILAG. So this is the advantage of having a package, because it's possible that we may have a naming conflict. The same name, the same classes, two classes that are supposed to be different. One is all of them called students. All the two classes called students. But then we have students in this package and we have students in that package. If we want to clearly distinguish between the student of this class, we refer to its own package, the name of the method, sorry, the name of the class. So that will differentiate. Obviously, we know we are calling the student of this class. Or in our import statements, this is why now, remember when we have java.util, import java.util.scanner. If you say .start, it means you are calling all classes of that scanner. But then the danger of using the all is possible that I have BUK as a folder here, as a package, and I have UNILAG here as a package. I'm interested only in students of UNILAG, not the student of BUK. But in this BUK, I need to get instructor from BUK, and I need to get student from UNILAG. Now, if I have the import statement and I import all classes in both the two packages, it means all of them will bring what? Student. So if I go to my class where I now instantiate an object of student, then again, another conflict. Because the student of which will be invoked or will be called then. Is this student of UNILAG? So in that case, I have to use what I call fully qualified. So where I need to use it, I have to use it as fully qualified, meaning I have to say UNILAG.student to clearly indicate that I'm calling, because in my import statement, I'm importing all classes. So if I'm putting all classes, means all of them would bring the student class. So, why do we need this to resolve this naming conflict? That's one. And again, uh, how do we create a package which is clear? We just have a package statement and operator. Then the naming package should always be a noun and should be like always written in lowercase, all in small letters. So how do we use package members? All these access modifiers, protected, which I'm sure I explained, only that I said I will repeat when I come to packages. Because at that moment, it was too early to discuss about packages, even though we are coming to where we need to discuss about these access modifiers. And to understand access modifiers, you have to understand packages first. Then how do we manage source files and class files? All these programs that we are writing, how do we manage them? How do we compile them? How do we run them? Then visibility modifiers. So how do we make use of this visibility? Protected access modifiers, protected, private, or default package, or public, and things like. So yes, in most cases, we call it an API. We say a classes in Java if are organized into packages. And most of these API application programming interfaces, we get them, we consume them when such kind of services are being provided for us to incorporate it into our own program. These are already built-in packages that are already exist in the Java API. All we need just use them, like java.util.scanner. That util is a package, and inside the util we have a scanner, we have a random number generation, we have a date. All these are classes and interfaces that we need them in our program. So these are APIs because they are being provided for our own consumption. So we only call them and use them. And later we're going to see where we can create our own package, in which a case whereby if you make use of NetBeans or Eclipse, they automatically add that package declaration on the very top of the project to indicate that that class will be saved in the package where it is being specified, like that. And in most cases, the name of the project always is named as the name of your package in when you make use of all these uh, IDEs. But if you take notes, there is somewhere where you can rename the package, so you rename it of your choice. Yes, they have that flexibility. So some of these application programming interfaces are like the Java applet. When you want to now run Java application over web, you make use of the applet. Remember, some will even say, okay, now is it like Java is more of a desktop application? Can I use it on the web? Yes, you can make use of the Java applets to run it on the web. But then even now that things are growing, technology is evolving. Java applet is almost obsolete now. There is a Java, uh, in fact, anyway, I can't recall this, but there is Spring Boot is a Java framework. Even JSP is Java Server Pages. It's basically based on Java. You can write a web application using the JSP. It's basically Java. If you understand Java, believe me, today you can take and write a program, full-fledged program using JSP, and it's a Java something. And one good thing, yeah, people can argue, but Java is fantastic. It's very fast. It's not. It's fast and it's secured in terms of all this. It can work on the web. Only that the community where we are now, at times, people are more of developing now web application using PHP or Python, as the case may be. And some use Ruby, but the community might not be as like uh, PHP and and Java and probably Python. So or that there are some frameworks like in Python we have Django or Flex. These are framework for for using or for developing a web application using Python. For Java, that is Spring Boot. For PHP, that is Laravel, Symfony, PHP Cake, and many, even Zen framework. There are many PHP Zen framework. There are many frameworks in which you can use, which they have their own security capability. Unlike maybe when you sit down yourself to write a program, to develop an application without making use of all this, you need to do a lot and you have to take into consideration of so many security issues. But this framework have provided, but again, still, even if you are going to make use of these frameworks, you have to work with extraordinary care because they also have their own lapses, and they are open source, and people know the lapses of, or if there is any negligence in the development, then it can easily be breached. Okay, so why use package? Easy to know where to find classes and interfaces that provide a particular set of functions. Yes, avoid conflict with class names in other packages. This is one. I've mentioned this. Now for that one, I also mentioned the first one where I say it is easier to locate classes and interfaces because you have organized your program. So if you know you are looking for a student, you know where to get it. You go to the BUK package or you go to Unilag package. So it's easy to go and access it and locate it and do whatever necessary. And again, to avoid this naming conflict, where we have a package conflict or a class conflict, so we can make use of this namespace to distinguish between this and this. And this is why now, if some of you have ever used some of the applications, like let me use my common Laravel framework PHP, and where you have the use keyword. If you have any conflict in the class where you are making use of a class and you have the use keyword, whatever you have imported, if you are importing, let's say for instance, I need to use students in my class. I've even given this an example. I said, okay, now I am interested in having a student. So if I now have the import statement of Unilag and I import all, and I also have in the student in the Unilag and BUK, but one thing I'm interested is to get the student of Unilag. But unfortunately, I'm importing a student of BUK, which is not a student of Unilag. So if for now there is a method, and that method is only available in the BUK, now on attempt to make use of that method, or mistakenly make use of, or since I'm importing a student of Unilag, but unfortunately, I'm making use of the student of BUK. So if I call the method, that method may not be available in the students of BUK, but only available in the student of Unilag. So even though I have the import statement of student, but the method I'm accessing is not in the student of BUK, then it's going to cause an error. And in most of the application, you will discover this. Yes, you see an import statement, quite sure you have it. You use, maybe if there's a PHP, you can see a use them, the name of the namespace, like provided. Okay, fine. You have it. And then you call a method, that method does not exist in that class that you have imported. That means you have wrongly called a package that is not supposed to be imported. So you now look at it. When you see an error, it's saying this is, oh, that means you are calling or you are importing a wrong package. So you now change it. So this is the case now. If you have that, then you know that this method, probably you check the package imports. You are importing a wrong package. This is why that method is complaining, cannot find something or cannot locate this or undefined method. This. So, of course, we use this. And again, the namespace would be provided on the very top so that wherever you want to make use of it, you make use of it by the namespace provided. So if I say maybe I have a Unilag something, I will say package this Unilag dot something dot something dot something up to dot student. So if I provide that, wherever I need to import it, I will import it without namespace. So in like PHP Laravel framework, you will see a namespace declaration there. So where you are going to import it, you import it with that namespace, then followed by the name of the method. Sorry, followed by the name of the class that you are interested in getting out of. So the package statement we said is always appears on the very top. And if you have it on the very top, like this shape now, we can have a package graphics. So that means whenever we write a program and we specify the package, if you check very well, you discover that the name of that package is a name of a directory or folder that when you compile, automatically that folder will appear in your program. So the dot extension files will be saved in that. So that is the source file that is now going to be stored in the package. Now, in the case whereby you don't specify the name of the package, then it's assumed the class belongs to a default package. So a default package will be created if you don't create. Like in most of the programs I have written, I think since the day I started, I have not written any program that has a package declaration because I don't use IDE when I come to teach like this. I rather start to come one step at a time because if you see me at early stage writing package, then you now begin to ask me question that say, sir, what is the meaning? Why do we have that line? And at that point in time to explain the package definition might be too early and might end up confusing the class. So because we have to go incrementally. We start from what we need most first, and then we move. As we move, we now bring in things. Of course, yes, there is no way we can, even if you look at the public static void main as you have earlier started in 211, when that one was written to you, I think probably the man was probably look at it the way that, okay, he's going to explain to you what is public, what is static, what is void, what is, it was too early then to explain. Though the person will tell you, okay, now just take it the way it is. When time comes, we now explain. Because this word static, what does that mean? So you might not know what is the use of static, and at that moment when you are doing introduction to Java and writing the first hello world program in Java, and that person will now begin to explain the use of the public static void main, then it might end up confusing you. So this is why it's good to take it gently and gently, unless if it is necessary that we have to bring, like, the import statement, we don't have a choice. We have to import some packages, even though we have not talked about packages. But we can just mention that, okay, just for you now to make use of this tool, you have to bring the box and pick the tool you want to make use of from the box. That's all. So the same thing. But now the idea, how can we create the box? How can we have the tools stored in the box so that whenever we need it, we import the box to make use of the tool. This is now the main business for this lecture. How can we create the box? How can we have the tools in the box? How can we import the box to make use of the tools? So the naming convention, most that's a convention is advisable to follow this concept in order to avoid confusion with the name of the class, because name of the class we say is a noun or noun phrase, but then since it's a noun, it should be what? Capitalized. But now a package should be written in lowercase. So this will now at least differentiate between the name of the class and the name of the package. So dot are used to separate between one package and the other. That is, we can have a nested package, like say having a folder inside another folder, folder inside another folder. So we can indicate this hierarchy with the use of dot statement, dot symbol. So if I have java.awt, it means I'm trying to access a package that is in the Java root directory. IO, input output, anything that has to do with input output. I don't know if you have ever used buffer reader to read input from user, you must have used this IO. Or if you have read, maybe you process a file where there is need to read and write to a file, you must have used this IO something, because you have to throw IO exception. Even file is there, and some other packages are also there in IO. Buffer reader and so many classes and interfaces are in the IO package. And .lang, which is the default package that you don't need to you don't need to call, and this is automatically imported by the Java application, java.lang, and this is where the object is. Remember, we said any class that is not set to be an object of or subclass of any class is a subclass of object. So where is the object? Where have we imported the object? The object is imported automatically in java.lang package. So we don't need to worry ourselves in importing the java.lang because it's automatically imported. So similarly, when we are dealing with something like this now with geometry, we can say AWT, that is Abstract Windows Toolkit, especially when we come to do GUI. We will see where if we want to give a color to a text files or want to give a color to some components, we can call this. So later we're going to see. Now, or geometry, AWT.geometry, AWT.events, where we deal with events handling programming, clicking, double clicking, mouse over, and things like these are the things. So that's that. The naming convention, if we have, like I said, to avoid this, the organization, like how do we now name our package? So we said, if suppose now, for instance, we have abu.edu.ng, and we want to now say student of ABU. So the way we're going to create a package should be written in the reverse way of the domain name of ABU. The domain name of ABU is abu.edu.ng. So the reverse way of that is to say what? ng.edu.abu. That is the reverse way of the name of the domain name of ABU. Then followed by the name of the class. So this is what it says that, okay, we have it in the reverse way, like .com, company.com, the name of that website of the company or the domain name of the company. Let's say it's companyname.com. So we now write it in the reverse and say com.company.package. So the package, the name of the package should be here, while this is just a prefix per se. Yes. So if we are to use a public package member, we must do one of the following. Either refer to the member by its long name, that is to say, whenever we are to make use of it in our program, we have to make use of the long name. For instance, I want to import student of Unilag, and I have a package called Unilag. Then I will have what? You remember, so if we are now to create a package of Unilag, remember, so what is the domain name of Unilag? It's probably could be unilag.edu.ng. So what should be the reverse order of Unilag domain name? Should be ng.edu.unilag. That's one. Then the name of the package. Say, for instance, that Unilag, for instance, is the name of the package. So the name of the class. If we are to refer to the name of the class using a long name, so that means you have to use a fully qualified, use a long name to import it by saying ng.edu.unilag.student. So that we are using a long name. If we don't make use of the import statement, or we have an import statement and then we now go and access the student class. So that's in my import statement, I will say import. Sorry, I don't want to minimize this. Rather, I will have just go and write a simple example, but I'm going to do that in the next 1 to 2 minutes. We still have like, oh, it's already fast time. Yes.
After you write the reverse of the unilag, are you going to put a full stop at the end of the student, or just?
No, there is no full stop at the end of the student. You just put semicolon. So I think it's let me so I think I should have an example here. So sorry guys, it's already time, but just give me 5 more minutes to round off this. I think I should have an example of this package. Yes, yes, great. So I have an example of this package of a thing. Okay. So now let's look at this. Can you see package? Okay. Let me bring package A. Now, can you see package definition? You see package, the name of the package is what? PKA. This is the name of the package. It's called PKA. Are you with me, guys?
Yes, sir.
So please just bear with me. In the next few minutes, we'll stop. Package PKA. Now, this should be the first statement. Earlier, we normally used to have import statement, but unless if you are used to the IDE, like NetBeans or Eclipse, where automatically they add the name of the package. So this is the name of the package. So anywhere I'm going to make use of this A, I must import the package. Otherwise, the A.class cannot be located. That means if I compile this program, this package will be created. That is to say, a folder will be created for me automatically here. A folder will be created where the A.class will be stored. And now if I come to B, this is B, package PKB. That means this also will be in the package what? PKB. But then I'm now going to say extend A. How can I tell B is an extension of A if B cannot locate A? So I have to tell A can be located from which file. So I have to import it so that A is available, is visible. Otherwise, B will complain, the compiler will complain, cannot find class A because they do not exist in the same directory. This one is in the PKB and this one is in the PKA. Yes, this one is in the PKB and this one is in the PKA. So therefore, trouble will come. So I have to now specify that, okay, A can be located in this package. So go to the PKA, that is a folder PKA, and there is going to be a class A. So therefore, this B is an extension of that class that located in PKA. So I can refer to this without any headache. So if I come here let me delete these guys. You see, I'm going to delete this pka and pkb. I'm deleting now. So there is no any folder as far as this is concerned. Now I'm going to compile the A with the package. So I have to say jarback. Then if you are compiling with the package, I have to say java dot. This dot means I need to specify the directory, the destination. D means destination. Where is the destination? So if I say dot, remember, if you know the kind of operating system, you know dot means current directory. Yes, that means current directory. So it means that the class, the package should be created in the current directory, because I can even tell the pka should be created where I can specify the directory anywhere in my directory. As long as it is writable, I can specify that. So I will now use of maybe say a.java. So just launch. Can you see pka? Yes. Yes.
Why this Java with C?
Java is compilation now. You know, this is compilation. We are compiling, not running. When you say Java, it means you are compiling Java compiler. You are calling Java compiler. If you say Java, it means you are trying to run. And -d means destination of the source file. That dot means current directory. So if I want it to be in my desktop, so I can say, I can make use of this. Then here, I will say C drive slash blah blah slash blah blah slash. So that means this pka, this pka something, instead of it to appear here, it will locate in my C drive. It will go to this and then go to this and then add that pka folder. But since I want it to be in the same directory where I have my a.java, then I have to say dot. So if I say dot already, you will see it here. Can you see? Let me delete and take it again. Please just be watching. If I compile, you discover that that A will appear. Can you all see my screen? So now I press enter. You will see the pka. Can you see pka appears? Can you see it? Look at it here now.
No, sir. No, there is no PT.
Okay,
Okay.
just a moment. Can you see this pka folder? Please respond with yes or no. Can you see pka folder?
Yes.
So now I'm going to delete. I'm going to
Yes,
delete it.
Yes.
I'm going to delete it. Can you see it's deleted now?
Yes, sir.
Now look at this program. Can you see in this program, class A? Can you see package pka?
Yes, sir.
So having this file declare, having seen this package pka, meaning that when you compile this program, you know it's going to generate a bytecode that is a.class. You know, when you compile a program, you know it's going to create another file. Do you discover that?
Yes.
Yes, so that class, that's one that will be created is called a.class, and that is what we call bytecode, and that is what is going to be consumed by the machine, because this program that you have written is not understandable by the machine. Your machine cannot understand it. That is why you need compiler to translate this program that you have written into a machine understandable form, and that is that a.class. And that a.class, when you open it, you just see jargons. You will not see anything meaningful there. But that is what is going to be understood by the machine. And the machine will happily interpret that jargons, that you are seeing it as jargons, but it's well something that has meaning to the JVM, that the JVM will translate it to your machine. So now, if this is the name of the package, that is going to be the name of the folder. So we're now saying, where do we want to create this folder? Do we want it to create it in the same directory here? If it is in the same directory here, fine. So we now say this is it. So I'll now make use of the dot here. Dot means current directory. Current directory, where is the current directory? Can you see it? Which one is the current directory? Packages here. Is it not the current directory? My current directory is packages. Can you see it here? Hello?
Yes, sir. Yes, sir.
Yes, my current directory is packages. So if I now say, okay, compile this program, so if it is successfully compiled, that package name should be created in the same directory in where my console is. So if I press enter, just watch by the left side, can you see that PKA appears?
Yes.
Automatically it will be created. So if you go in there, can you see that a.class?
Yes, sir.
So this a.class is a class file, it's not a Java file. Look at the type, the type is saying class file. So when you open this, remember this is what is going to be used by the JVM, Java Virtual Machine, which is going to be our next topic that I say I'm going to give it as a reading something. Can you see jargons? Can you read this?
No, sir.
So this, you are seeing this as jargons, but this is what is going to be consumed by the machine. And this is the translation of the program you have written. It is what is being written here. This that you are seeing is SOH something, you are seeing as jargons. If I ask you to read, you will not read. Look at some one character, crazy character here. Look at it. Look at it. But all this has meaning. This is what is going to be read by the Java virtual machine and translated to your machine. And that machine will execute and then will bring out the output. Not a.class. This one is for your own consumption. You programmer, you write this. But machine will understand this. And remember, even the machine, remember, this is not the language of the machine. This is the language of the JVM, Java Virtual Machine, that will now read this and translate it into binary code. And that binary code is the machine code. So remember, even this one is not for the machine, it's for the JVM, Java Virtual Machine, to interpret this, because this is understood by all JVM. This is why we say Java is platform independent. You take these jargons, take it to any machine, execute it, it's going to work. As long as that machine has a JVM. Remember, this is why you need to have the JDK installed. So once there is JVM, that's all. You can execute this program, regardless of where it is being written. It is not tied to a particular specification of machine, because your JVM will interpret it based on the specification of your machine. So I think where I need to say to demonstrate with examples, and time is not by our side. So the same thing you can do for B. You can say this b.java. So it means, sorry, I need to put this side by side. So let me delete B also. This is B. Now I compile this, just be watching, you will see B appears automatically. Yes, so if you go in there, you will see the B.class. So, but then, let me come here and say that this, let me comment this. Can you see this? This is B class, and I'm saying B extend A. And can B going to locate A? Is A going to be known by a class B? If I commented this import statement, can it locate? So let's see. Now I've commented that. I'm going to compile. So I have to delete this so that if I don't delete it, then even if I don't delete it, at least there is no import statement. So now I'm going to compile this. What can you see?
Error, cannot find symbol.
Symbol. Which symbol cannot find?
Public class B extend A.
So if you look at this caret, is it not indicating A? This means A cannot find symbol A. The problem now cannot find symbol A. So it's saying symbol class A cannot be found. Simply because I commented this import statement. Because it's in the package, unless if there is no package statement, they're all going to be in the default package. So the class can be located. All the ones we have written, they are all in the same default package, so no problem. They can be located. Now that I'm not using the default package, I'm having my own defined package. So I have to specify the package name. If I don't have this import statement, then this will lead to an error, meaning it cannot locate A. But if I have this, then there will be no any issue. We'll compile and the program will go. So I think class will stop here. We have said enough. We have said a lot and we cannot say all. Thank you.